So, good afternoon, everyone. So, in the previous class, we have started the FAQs of semiconductor devices. In that, we have discussed regarding half-wave rectifier, what is the meaning of rectification, and what was half-wave rectifier, and what was full-wave rectifier. So, we have seen that rectification means the process of conversion of AC to DC, and the device used for doing this rectification process was called as rectifier. And we have discussed regarding two rectifiers. One was called as half-wave rectifier and other was called as full-wave rectifier. In case of half-wave rectifier, we were using only one single diode, PN junction diode, and during positive half cycle, the diode was behaving in forward bias and it was conducting electric current. Similarly, during the negative half cycle, the diode was behaving in reverse bias and it was not conducting any electric current. So we have seen that the efficiency of half-wave rectifier was around 40.6%. What does it mean? It means that whenever you are giving 100% AC supply, it is converting around 40.6% into DC. Then we have seen full-wave rectifier, and we have seen that in case of full-wave rectifier, we are having two diodes. During positive half cycle, diode D1 was behaving like a forward bias and diode D2 was behaving in reverse bias. Similarly, during negative half cycle, diode D1 was behaving in reverse bias, whereas the diode D2 was behaving in forward bias. So finally, the output consists of full wave. For positive half cycle, we were getting the output. For negative half cycle also, we were getting the output. So efficiency of full wave rectifier was around 81.2%. So these are the things which we have seen in yesterday's class regarding semiconductor devices. The another important concept which you may expect in your examination is regarding logic gates. See here, I will share, first of all, I will be giving some basic introduction regarding logic gates, then I will be discussing one important question, one important concept regarding logic gates, which may be asked in the examination. See here, logic gates. See, in order to do some mathematical operations, we'll be using logic gates. What are the basic fundamental logic gates? We know that there are three types of logic gates, fundamental logic gates. What are those? AND logic gate, or I can write directly AND gate. Next one is OR gate, and third fundamental gate is NOT gate. So why we'll be using AND gate? We use AND gate for performing multiplications. And we'll be using OR gate for performing addition operations. Similarly, NOT gate is also called as inversion gate. So these are the three fundamental logic gates. What are the three fundamental logic gates? One is called as AND gate, other one is called as OR gate, and the third one is called as NOT gate. AND gate is used for performing multiplication operations, and OR gate is used for performing addition operations, and NOT gate is used for performing inversion. It is nothing but it is inversion gate. See here, in case of logic gates, further we are having two universal gates. Now everyone listen carefully. This is going to be your question in your examination. First one is called as NAND gate. This is the question you may expect in your examination. NAND gate. How we will be forming a NAND gate? NAND gate is formed. It is formed by combining AND gate and NOT gate. You are supposed to write this thing in the answer sheet. How does a NAND gate is formed? It is formed by combining an AND gate and a NOT gate. Let us see here. We know that symbol. We know the symbol for AND gate. We know the symbol for NOT gate. So whenever This is the symbol for AND gate. Here, how many inputs are there? There are two inputs, A, B. To this AND gate, what I have did, I have attached a NOT gate. This combination is called as NAND gate. And the output is given as Y is equals to A dot B bar, because multiplication means A dot B. Why I am taking here bar? What is the work of NOT gate? It will invert the thing. So here the output will be A dot B, and here the output will be A dot B bar. The other symbol for otherwise, this symbol can also be written as something like this. How many inputs are there? There are two inputs. What are those inputs? Input A, input B. And what you are supposed to do? You are supposed to draw a bubble here. So here finally we will be getting an output Y is equals to A dot B bar. So this is the arrangement for NAND gate. So how a NAND gate is formed? NAND gate is formed by combining AND gate and NOT gate. So next what you are supposed to do? You are supposed to write down its truth table. Truth table, or you can also write mathematical operation also. See here, how many inputs are here? We are having two inputs. How many outputs we are having? Here we are having only one output. So I am writing here input column, and here I am writing output. How many inputs are there? We are having two inputs, input A, input B. And how many output we are having? Only one output. Y is equals to A dot B bar. See here. Now everyone see here carefully. Otherwise, I will directly write, because we are studying for our supplementary examination. Otherwise, I would have explained A dot B. Further, I have written A dot B bar. See here. What are the inputs for this truth table? I can give input 0 to A and input 0 to B. So what is that multiplication? 0.0 will become 0 actually. But here bar is there, it will invert the things. So our final answer will be what? 1. Similarly, if I give input A as 0 and input B as 1, we know that 0.1 will become 0. But here bar is there, it will invert the things. So this will become 0 into 1 will become 0. If I invert that, I will be again getting the output what? 1. If I take input A as 1, input B as 0, again see here 1 into 0, 1.0 will become 0. But what is there? Here NOT gate is there. What NOT gate will do? It will invert the things. 1 into 0 will become 0. If I invert that, it will become what? It will again become 1. Finally, what I am doing? I am giving input 1 to A, input 1 to B. So 1.1 will become 1. But what this output will do? It will invert. What this NOT gate will do? NOT gate will invert the things. 1.1 will become 1. If I invert the 1, what is the output we are getting? We are getting the output as 0. So here I can conclude the explanation of NAND gate as, what is NAND gate? It is formed by the combination of AND gate plus NOT gate. Next, what you are supposed to do? You are supposed to write down the symbol for AND gate and draw a NOT gate, attach a NOT gate to it. Finally, these two are the symbols for NAND gate combination. Again, what you are supposed to write? You are supposed to write the mathematical operation or the truth table for which gate? NAND gate. Whenever both the inputs are 1, output will be 0. So here you write down this point. In case of NAND gate, output is 0. Output is 0 when both the inputs are 1. When both the inputs are 1. I hope you understood this NAND gate operation. So if you are done with this, let us move on to the next universal gate, that is called as NOR gate. So this was the explanation for NAND gate. Now let us study about the NOR gate. See here. Second universal logic gate is NOR gate. How does a NOR gate is formed? It is a combination of, I hope you will write this. It is a combination of OR gate and NOT gate. So what is NOR gate? NOR gate is the combination of OR gate and NOT gate. So next what you are supposed to do? You are supposed to draw its symbol. Again, it consists of two inputs. It consists of two inputs. I am writing input A. This is input B. In previous case, we have written NAND gate. See here in NAND we are having D. That is the reason. That is not the reason. Just remember this. In case of NAND gate or AND gate, we'll be having D symbol here. But in case of NOR gate, we'll be having a leaf-like structure, something like this. Something like this. To this OR gate, what we are doing? We are attaching a NOT gate. So this symbol will behave like a NOR gate. And what will be the output here? Y is equals to. We know that OR gate is used for performing arithmetical operation. That is nothing but addition. So to that addition, what I am doing? I am adding a NOT gate. So it will invert the thing. So what will be my output? My output will become A plus B bar. A plus B bar. So what is the other equivalent diagram for NOR gate? I can draw this gate something like this. How many inputs are here? We are having two inputs, A and B, and a leaf-like structure with a bubble here. Again, this will also behave like an NOR gate. This will also behave like a NOR gate. What is the next thing we are supposed to do? We are supposed to write down its truth table. So next I am writing what? Truth table. Truth table. Or you can write mathematical operation. It's mathematical operation. Again, how many inputs are there? Here I am writing input. Here I am writing output. How many inputs we are having? We are having two inputs, A, B. How many output we are having? We are having only one output. What is that? Y is equals to A plus B bar. Y is equals to A plus B bar. So what is that? Please apply that. Initially for input A, I am giving 0 and input B also I am giving 0. So 0 plus 0 will become 0. But what this NOT gate will do? It will invert the things. So 0 plus 0 will become 0. So our output will be what? 1. If I give input A as 0, input B as 1, 0 plus 1 will become 1. But what NOT gate will go? It will invert the things. 0 plus 1 will become 1. What NOT gate will do? It will invert the things. So again I will be getting the output 0. If I am taking input A as 1, input B as 0, again 1 plus 0 will become 1. But what is the work of NOT gate? It will invert the things. 1 plus 0 will become 1. Again I will be getting the output as 0. Next, I am taking input A as 1, input B as 1. Again, what will be my output? It will be 1 itself. But again, what NOT gate will be doing? It will be inverting the things. So remember here one point. In case of NOR gate, what is happening? See here, in case of NOR gate, when both the inputs are 0, output is 1. If any one of the input is 1, then the output we are getting is 0. So the last point you are supposed to write in case of NOR gate is, write down, note down this point. What is that? In case of NOR gate, output will be 1 only if both the inputs are 0. So this is the last point you are supposed to write in the examination. So we have discussed two concepts now. One is called as NAND gate, other one is called as NOT gate. In the examination, you may get a question, what are NAND and NOT gate? Write down their truth table. So what is NAND gate? How a NAND gate is formed? NAND gate is nothing but it is a combination of AND gate plus NOT gate. In case of NAND gate, when we will be getting both the inputs, what is the condition here? In case of NAND gate, output will be 0 whenever both the inputs are 1. Similarly, next we have discussed regarding NOR gate. NOR gate is nothing but it is a combination of OR gate and NOT gate. And in case of NOR gate, we will be getting the output as 1 when both the inputs are 0. I hope you understood these two concepts. Many times they have asked this question in the examination. Okay. There is one more small concept that is called as NOT gate, which may be asked in small VSQ, small answer type question, very small answer type question. What is the third one? Not third one. This is basic fundamental logic gate itself. That is NOT gate. NOT gate. So just what you are supposed to do, you are supposed to write the symbol. What is the symbol for NOT gate? Just now we have seen symbol for NOT gate. NOT gate consists of one input and it is having a symbol something triangle. Here it is having only one input. If the input is A, I said that NOT gate, what NOT gate will do? It will invert the thing. So again, I will be getting output as what? Y is equals to A bar. If you want to write down the truth table for this, truth table of which gate? NOT gate. So how many inputs are here? We are having only one input. This is input. This is output. We are having only one input and only one output. Whenever input is 0, what will be the output? It will invert the things. Output will become 1. Whenever input is 1, what will be the output? Output will become 0. I hope you understood this concept. Just I am teaching in point of view of that examination itself. So most important question after half wave and full wave rectifier is what are NAND and NOR logic gate? Write down its truth table. And the next important small VSQ, small answer type question is NOT gate. So NOT, what is the other name for NOT gate? It is also called as inversion gate. Okay. Now let us discuss few more important concepts from semiconductor devices. See here. Semiconductors. We know that there are three types of metals. One is called as insulator. If I ask you a question whether insulator will allow electric current to pass through it, you will be saying no sir, it does not allow any electric current to pass through it. Okay, if I am asking you another question, what do you say about conductors? Whether conductor will allow any electric current to pass through it, you will be saying yes, definitely sir, it is a conductor, it will conduct the electric current. The reason you might know, in one case there will be bound electrons, in other case there will be free electrons. Now in between insulator and conductor we are having what? Semiconductor. Depending on some properties or parameters, semiconductors sometimes behave like an insulator and sometimes they will be behaving like a conductor. So generally we consider semiconductor elements as silicon and germanium. We consider silicon and germanium as semiconductor elements. See, whenever we are adding impurities, when we add impurities to these semiconductors, SE represents semiconductor. Whenever we add impurities to this semiconductor, again they will be further classified, that are called as extrinsic semiconductor. But the process of adding impurities, whenever I am adding the impurities to pure semiconductor, the process of adding of impurity is called as doping. Remember this. What is the meaning of doping? The process of adding impurities to a pure semiconductor is called as what? Doping. See here, once we are adding these impurities, next what is happening here? It will behave like an extrinsic semiconductor. The process of adding impurity is called as doping. And once we are doping that semiconductor, it will behave like an extrinsic semiconductor. Again, depending on impurities, whether I have added a trivalent impurity, whether I have added a pentavalent impurity, semiconductors are further classified. Let us see here. If I consider an example of germanium, how many valence electrons will germanium will have? It will be having 4. 4 valence electrons. 4 valence electrons. Let me take one example. I am having boron. Boron. How many valence electrons will boron have? It will be having 3 valence electrons. 3 valence electrons. That is the reason it is called as trivalent element. How many valence electrons are there for boron? Only 3 valence electrons are there for boron. Now what I am doing? I am adding boron impurity to germanium. I am adding boron impurity to germanium. Let us see what will happen here. This is boron. How many valence electrons this is having? This is having 1, 2, 3 valence electron. And this boron is forming covalent bond with germanium. This boron is forming what? Covalent bond with germanium. See here. This is germanium. Now, one electron, valence electron of germanium forms covalent bond with another valence electron of boron. Okay. Similar thing will happen here. One valence electron of germanium forms covalent bond with one electron of boron. Okay. Same thing will happen here. One valence electron of boron forms covalent bond with one valence electron of germanium here. Okay. See here, what is happening here? Here I am having germanium. How many valence electrons are there for germanium? 4. Here it is having 1 electron, but there is one vacancy because boron is having only 3 valence electron. 1, 2, 3. These 3 valence electrons are forming covalent bond with germanium, but there is one vacancy created here. Here there is nothing but this is called as hole. This is called as hole. So whenever a semiconductor is doped with which type of semiconductor? Pure semiconductor. Whenever a pure semiconductor is doped with which type of element? 3 valence electrons, means trivalent element. Whenever we are doping a pure semiconductor with trivalent impurity, which type of semiconductor will be getting? Will be getting p-type semiconductor. P-type semiconductor. So remember this. Whenever a pure semiconductor is doped with trivalent impurity, we'll be getting which type of semiconductor? We'll be getting p-type of semiconductor. P-type semiconductor. Next important point in this. What are majority and minority charge carriers? Majority and minority charge carriers. Charge. In which case? In p-type semiconductor. See here. For each boron atom, one vacancy I am getting. Definitely I will be adding some amount of impurity. So which type of vacancies will be more? Holes will be more. So majority charge carriers in p-type semiconductors are holes, whereas minority charge carriers in p-type semiconductors are what? Electrons. Remember this. All these things are your important questions for your examination. What are the intrinsic and extrinsic semiconductor? Intrinsic semiconductor means pure form of silicon and germanium. What is the meaning of extrinsic semiconductor? Extrinsic semiconductor means whenever we are adding impurities, then that type of to the pure semiconductor, that type of semiconductor is called as extrinsic semiconductor. Based on impurities, extrinsic semiconductors are further classified. When I am adding trivalent impurity, which type of semiconductor I am getting? I am getting p-type semiconductor. What are the majority charge carriers in p-type semiconductor? Holes. What are the minority charge carriers in p-type semiconductor? Those are electrons. I hope you understood this p-type semiconductor. Let us move on to the next type of semiconductor. Again, I am considering the same thing, germanium. How many valence electrons are there? 4 valence electrons. Now this time I am adding an impurity of pentavalent atom. I am taking example of bismuth. Bismuth. It will be having 5 valence electrons. 5 valence electrons in its outermost orbit. Now what I am doing? I am adding this bismuth impurity, pentavalent impurity to germanium. Let us see what will happen here. Everyone carefully see here. See here. This is my bismuth. Bismuth. It is forming covalent bond with germanium. Forming covalent bond with what? Germanium atom. We know that germanium has how many valence electrons? 4 valence electrons. So the 4 valence electrons of germanium forms covalent bond with 4 valence electrons of bismuth. See here. 4 valence electrons of germanium are forming, 4 valence electrons of bismuth are forming covalent bond with germanium. But how many valence electrons are there in bismuth? There are 5 valence electrons. So one extra electron is here. Let us assume that electron is here. So what is here? Here we are getting excess number of electrons, or in previous case what was happening? We are getting one hole here. So that is the reason we call this one as p-type semiconductor. But in this case, whenever I am doping germanium with pentavalent impurities, I am getting one extra electron. I am getting one extra electron. Due to this reason, this type of semiconductor is called as what? N-type semiconductor. N-type semiconductor. I hope you understood this thing. So whenever we are adding impurities, based on the impurities, semiconductors are further classified as p-type semiconductor and n-type semiconductor. Remember, how a p-type semiconductor is formed? Whenever we are adding trivalent impurity to a pure semiconductor, that is nothing but we will be getting p-type semiconductor. Whenever we are having pentavalent impurity to a pure semiconductor, we will be getting which type of semiconductor? N-type semiconductor. And what are the majority and minority charge carriers in case of N-type semiconductor? Here, majority and minority charge in case of which type of semiconductors? N-type semiconductor. So what is the excess thing we are getting here? We are getting electrons. So majority charge carriers are what? Electrons. And what are the minority charge carriers? Minority charge carriers will be holes. I hope you understood this. How many types of what are semiconductors and how many types of semiconductors are there? We will be depending on impurities. Semiconductor. What is the meaning of doping? The process of adding of impurity is called as doping. Depending upon doping, whether we have added trivalent impurity, whether we have added pentavalent impurities, semiconductors are further classified as p-type semiconductor and n-type semiconductor. In case of p-type semiconductor, what are majority charge carriers? Holes are majority charge carriers. And what are minority charge carriers? Electrons are minority charge carriers. Whereas in case of n-type semiconductor, we will be having excess number of electrons. So what are majority charge carriers in n-type semiconductor? Means you are supposed to write electrons. And what are minority charge carriers in case of n-type semiconductor? Means you are supposed to write holes. I hope you understood this concept. Let us move on to the next important FAQ chapter. Most probably this will be question number 13 in your IEP examination 1-3. So the next important, see here, right now I'm discussing most important questions which you are supposed to concentrate first. Once we are done with all the important concepts, if we are left with time, we'll be discussing other important questions or very less important questions from all these chapters. So first of all, concentrate on these questions. Later on, we can move on to other questions. See here. So the next important chapter which I am going to discuss is electric charges. Electric charges and fields. Electric charges and fields. So this is also an important chapter. There are around 5 to 6 questions, very easy questions, and definitely will be getting one FAQs from this chapter. So let us start this chapter. I will start with some basic question which you have already studied in your lower classes also. What is that? First concept that we are going to discuss is Coulomb's law. Coulomb's law. I hope everyone know what is Coulomb's law. What is Coulomb's law? What does it tell? Let us consider. I will explain with the diagram. After that, I will be writing the answer. Let us consider two charges. This is charge Q1. I am having one more charge. This is charge Q2. Both of them are separated by some distance R. Now, if I ask you a question, if I consider two positive charges and if I try to bring them together, what will happen? They will attract or repel. You will be telling, sir, both of them are having same charges, so definitely they will repel each other. If I bring two negative charges, again they will repel because there is some force acting between them. If I bring one positive charge, if I bring one negative charge, what will happen to positive and negative charges? Both positive and negative charges are opposite charges. They will attract with some amount of force. So whenever there are two equal charges, they will repel with some amount of force. Whenever there are two opposite charges, they will attract each other with some amount of force. Now Coulomb's law tells about how much amount of force is acting between them. So see here, What is the first statement? We can write, according to Coulomb's law, the force of attraction, this is statement, the force of attraction between what? Between two charges. Between how many charges? Two charges, whether they are moving or at rest. They are moving or at rest. They are at rest. The force of attraction, or you can also write force, otherwise I will be writing this thing, because there is a possibility of attraction as well as repulsion also. So I can write the force of attraction or repulsion. Repulsion between what? Between two charges, whether the charges are moving or are at rest. Between two charges at rest, what will happen? Let us see now. Everyone remember this statement in the manner I am writing. First of all, what you are supposed to write? The force of attraction or repulsion between two charges. First point you are supposed to write is what? Directly proportional to, is directly proportional to the product of the charges. Directly proportional to the product of the charges. Product of the charges. What does it mean? It means that force of attraction or repulsion is directly proportional to what? Product of the charges, Q1 into Q2. Now let us write down the second statement for this. Next statement is, here the force of attraction or repulsion between two charges at rest is directly proportional to what? Product of the charges. And next statement is inversely proportional and inversely proportional to the square of distance, to the square of distance between what? Between two charges, to the square of distance between what? Two charges. So what is the statement for Coulomb's law? The force of attraction or repulsion between two charges is directly proportional to their product and inversely proportional to square of the distance between them. Means what? F is inversely proportional to 1 by r square. Why we are writing F is inversely proportional to r square? Assume that I am having two charges here. Both of them are positive charges. If I bring the two charges here, the distance between them is, assume that this is r1. What will happen? They will move away from each other with some amount of force. Again, what I am doing, I am bringing the two charges here. Again, they will move away. But if I compare the previous case, initially both of them were close to each other. The force of repulsion was very high. But if I take the charges at somewhat more distance, let me draw this thing here. Assume that here I am having charge Q1, here I am having charge Q2. The distance between them is R1. What is the force acting between them? I am writing the force acting between them is F1. Both of them are having same charges, they will repel each other. Next, what I did, I have taken the same charges, but this time I have increased the distance. This time what I did, I have increased the distance. Now the distance is R2. Again, the force acting here is F2. Now, if I ask you a question, whether the force F1 will be more or F2 will be more, you will be telling that as the distance is increasing, the force is getting reduced. I can explain this example with a bar magnet also, but let us keep this concept here itself because we are discussing regarding charges. I hope you understood this point. So what is the statement for Coulomb's law? The force of attraction or repulsion between two charges at rest is directly proportional to product of the charges and inversely proportional to square of the distance between them. Now let us see here. Let us prove this statement. What will be our final formula? Our final formula will be something like this. F is equals to K into Q1 Q2 divided by R square. If you want to write it initially, you can write. Otherwise, let us prove this. Proof. What you are supposed to write in proof? Let us consider two charges Q1 and Q2 separated by a small distance R. Then the force acting between them is given as. You can write this one. Let us consider two charges Q1 and Q2 separated by a small distance R. Then what is happening? First point, force is directly proportional to product of the charges Q1 into Q2. What is the second point? force is inversely proportional to square of the distance between them. Let us combine both these points. What this will become? This will become F is proportional to Q1 Q2 divided by R square. Everyone know that whenever we are removing this proportional symbol and including an equals to sign, we are supposed to include what? A constant. I'm writing this answer here. So if I remove this proportional symbol and write is equals to, what it will become? This will become F is equals to some constant K into Q1 Q2 divided by what? R square. This is the force acting between the two charges at rest. What is K here? Here K is a constant whose value is K is equals to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Its value is equals to 9 into 10 power 9. And what will be the unit here? See here. If I want to write this formula in terms of K, this will become F R square divided by Q1 Q2. So what will be the unit for K? What is the unit for force? Unit for force is Newton. What is the unit for R square? The unit for R square will become meter square, distance square, divided by, this is also a charge, this is also a charge. What is the unit for charge? The unit for charge is Coulomb. So this will become what? Coulomb square. So by this, we finish this important SAQ. What is the first important SAQ that we have discussed? That is nothing but state and explain Coulomb's law. So what is the statement for Coulomb's law? The force of attraction or repulsion between 2 point charges is directly proportional. Charges at rest is directly proportional to what? Product of the charges, and inversely proportional to what? Square of the distance between them. You are supposed to draw the diagram and write down all these things. After writing this, you'll be getting 4 marks. I hope you have copied down this. Let us move on to the next question. So let us discuss another question from this chapter, that is Gauss law. Gauss law. I hope everyone will remember one equation. I am going to write one formula. If you are able to remember that formula without reading this answer, you can directly write the answer. So what is that formula, sir? Means just remember this formula. What is that formula? This formula. Phi is equals to integral E bar dot ds bar is equals to 1 by epsilon naught Q net. If you are able to remember this formula, then you can write the entire answer without reading a single point. Without reading a single point, you can write the entire answer. Let us see. Let us see here. First of all, we'll be writing statement. After that, we'll be writing some important points. In examination, we'll be getting state Gauss law and write down some importance of that law. So this point, this symbol is called as electric flux. Electric flux. And we know that this circle is called as closed. This represents what? Closed surface. It represents what? It represents closed surface. Closed surface. Okay. What is the name of this symbol? Everyone know what is the name of this symbol? This symbol represents equals to. Equals to. And what is this? Again, you are just, this is nothing but 1 by epsilon naught. And what is this Q net? It represents net charge enclosed. What does it represent? Net charge enclosed. See here, if you are able to remember this formula, you can directly write down the statement. I'll be telling the statement, everyone carefully listen me. What is this? This is called as electric flux. What is this? This is closed surface. And what is the name of this symbol? The name of the symbol is equals to. And what is this Q net? It represents the net charge enclosed. So if I want to write the statement of Gauss law, statement. How I will be writing the statement for Gauss law? See here. What is this? Electric flux. The total electric flux. Electric flux. ये electric flux किसमें से जा रहा? Through a closed surface. The total electric flux through a closed surface. A closed surface. What is happening? The total electric flux through a closed surface is equals to what? 1 by epsilon naught is equals to what? 1 by epsilon naught times the net charge enclosed. The net charge enclosed. So without by hearting anything, we can easily write down this statement. What is Gauss law? The total electric flux through any closed surface is equals to what? 1 by epsilon naught times the net charge enclosed in the surface. Let me give an example. Assume that this is a closed surface, because Gauss law is applicable only for what? It is applicable only for closed surface. Remember this point. Let me consider one closed surface. Here there are some charges. Here there is charge Q1. Here I am writing charge Q2. Here I am writing charge Q3. Here I am writing charge Q4. Here I am writing charge Q5. So which charges should I consider? Should I consider charge Q1, Q5, Q2, or should I consider charge Q3, Q4, or should I consider all the charges? No, we are just supposed to consider only charges which are placed inside what? Closed surface. So our Q net will become what? Q net will become what? Q3 plus Q4. I hope you understood this. Gauss law is applicable only for which type of charges? The charges which are present inside a closed surface. Okay. Now let us write down the importance of this Gauss law. See here. Again, without reading anything, directly by looking at this formula, you can write down its importance also. See here. Importance. Importance of which law? Gauss law. What is the first importance? See here. What does it E represent? E represents electric field. What does Q represent? Q represents charge. So this is our first point. What is it? This is our first point. What is our first point? It gives the relation between what does E represent? Electric field and what does Q represent? Charge. So what is the first importance of Gauss law? Gauss law gives the relation between electric field and charge. Let us move on to the next important point. Second important point. Our second important point is this one. Which type of surface? Closed surface. So you can write it is applicable only for which type of surface? Only for closed surfaces. Closed surfaces. So what was the first importance of Gauss law? It is giving the relation between electric field and charge. And what is the next importance of Gauss law? It is applicable only for closed surfaces. Let us see the third important point. It is applicable for the charges both at rest and in motion. So Gauss law is applicable for charges which are at rest as well as for the charges which are in motion. So our last importance of Gauss law is it can solve complex. I can explain this last point, but no need, just remember this. It can solve complex charge configuration easily. So if you are writing these 4 points plus the statement along with this formula, you will be easily getting 4 marks. This is also an important question from electric charges and field. So what was Coulomb's law? Coulomb's law was giving us the force acting between two charges which are placed at certain distance. It may be attractive force or it may be repulsive force. And why we are using Gauss law? Here What is the statement for Gauss law? The total electric flux through any closed surface is equals to what? 1 by epsilon naught times the net charge enclosed in the surface. And what are the importance of Gauss law? The first importance is it gives the relation between electric field and charge. And what is the second importance of Gauss law? It is applicable only for closed surface. And what is the third importance of Gauss law? It is applicable for charges which are both at rest as well as in motion. And what is the importance of fourth importance of Gauss law? It can easily solve complex charge configuration, or you can write it can solve complex charge configuration easily. I hope you understood this answer. So let us move on to the next important concept from this chapter. See here. Next important concept, that is electric field intensity. Electric field intensity. So first of all, you are supposed to write down the definition for electric field intensity. If you remember the formula, then you can easily write down the definition for electric field intensity. Wherever there are some formulas and you are supposed to write down the definition, don't by heart the definition, remember the formula. So what is the formula for electric field intensity? It is given as E bar is equals to F bar divided by Q. What will be the units? What is the unit for force? Unit for force is Newton. And what is the unit for charge? Unit for charge is Coulomb. Remember this formula. If you remember this formula, you can easily write down the definition for what? Electric field intensity. See here. F represents for everyone know. E represents electric field intensity. Here Q represents unit positive charge. What does Q represent? Here Q represents unit positive charge. So how I can define this electric field intensity? How I can define this electric field intensity means electric field intensity is defined as what is this? Force. So electric field intensity is defined as force acting per unit positive charge. I hope everyone understood this. What is the, if you remember this formula, you can directly write down the definition for electric field intensity. What is this? E represents electric field intensity, F represents force, and what does Q represent? Q represents unit positive charge. So I can define electric field intensity as force. Electric field intensity is defined as force acting per unit positive charge. And what are the units for electric field intensity? Newton per Coulomb. Remember this unit also, Newton per Coulomb. Along with this definition, he'll be attaching one small question to it. Obtain the expression for electric field intensity due to point charge. This will be the question. What will be the question? Define electric field intensity. Obtain an expression for electric field intensity due to unit point charge. So next thing I am discussing here itself, expression of electric field intensity. What this EFI represents? Electric field intensity due to which charge? Due to a point charge. Due to a point charge. Now let us obtain an expression for this. Let us obtain an expression for point charge. See here. Consider there is one charge Q at some distance R. At some distance R, there is one unit positive charge. I have brought one unit positive charge. What does this Q represent? This Q represents unit positive charge. Both of them are separated by how much distance? R distance. So what you are supposed to write here? You are supposed to write in English. Let us consider charge Q, which is placed at a distance of R from a unit positive charge. What does this Q represent? This represents unit positive charge. This represents what? Unit positive charge. Now what will happen? Definitely some force will act between them. What is the force acting between them? I can write the force between the two charges is given as K into capital Q into small q divided by r square. I hope everyone know what is the value of K. K is constant. What is its value? K is equals to 1 by 4 pi epsilon naught. Remember this. Now what we are supposed to determine? We are supposed to determine the electric field intensity. So what is the formula for electric field intensity? E is equals to F divided by Q. So what is the value of F we got? KQQ divided by R square divided by what? This Q represents what? Unit positive charge. So this Q and this Q will get cancelled. Finally, I can write electric field intensity due to point charge. Which charge? Point charge is given as KQ divided by R square. So this is the end of another important concept from electric charges and field. What is this? So what is the final answer for electric charge intensity? Our final answer for electric charge intensity is E is equals to KQ by R square. I hope you understood this answer. So let me check the time. If you are having time, we'll discuss the other thing. So by this today, we have discussed the remaining answers from semiconductors. After discussing the answers from semiconductors, what we did, we have started electric SEQs of electric charges and field. In electric charges and field, what are the questions that we have discussed? We have discussed Coulomb's law. Next, we have discussed Gauss law. Further, what we have discussed electric field intensity, and we have obtained an expression for electric field intensity due to point charge. So in tomorrow's class, we are going to continue this electric charges and field. We are having further 3 more questions. That is nothing but obtain an expression for torque whenever an electric dipole is placed in uniform electric field. And the other important question that we are going to discuss is determining the electric field intensity along axial line. And the other last important question from this chapter is determining the electric field intensity along equatorial plane. So let us finish today's class here. I hope you are revising regularly. Please do revise that LAQs along with these SAQs perfectly. We'll meet tomorrow. Thank you.